Hello world. Today we are doing number 26, removing duplicates from sorted array. This problem was given by Apple in a coding interview, and in the previous episode we have done this in C#. Today we are coding it in JavaScript. I'm going to use the same solution that I explained in the previous video, and I went into a lot of details in it, so if you want to understand the problem even better, then head on and watch it. Here I'm going to first explain the problem. I'm not going to read it through because there is a lot and the internet never really wants to hear you read. So we are given an array with duplicates in it. So I'm just going to do this. And what am I expected to do is to actually, these are sorted. So I want to keep the sorted array. I don't want to unsort it or have something like this. I want to keep the order. And I want to remove all of the duplicates. And then what I'm going to return is the integer, so the number of elements that are not duplicated and are in the correct order. So let me just give you a very brief example here. From this array, what I want to have is this array. So 1, 2, 3, 4. And then I can have a lot of gibberish here. We don't really care because I'm going to be returning 1, 2, 3, 4, 5. So I'm going to be returning 5. This number is going to be expected from the server. What this number states is that I am going to be looking at the first 5 elements in the array, and they should be without duplicates and in the right order. The rest, we don't really care about it. So that's pretty much the problem. Let me just give you a very brief example again. And here I'm going to go with 1, 1, 1, 2, 3, 4. And then I'm going to have a lot of 5s and a 6. And what I'm expected to return is 1, 2, 3, 4, 5, 6 with the number 6. The first 6 elements are going to be sorted without the duplicates. And then I can have whatever I want to have here. It doesn't really matter. So how are we actually going to do that? I did paint this solution actually in the C# video. I'm not going to paint it here, but I'm going to show you what am I going to do. So the algorithm is going to do the following. I'm going to have 2 pointers, and I'm going to point the first one to the first number and the second one to the second number. So now the idea is, while both of the pointers are actually pointing to the same number, it means that the range between these pointers have a duplicate. So if I have 0, 0, 0, 0, 1, 2, if I have first pointer, so let me just go first pointer is going to be equal to index 0, and then I have second pointer is going to be equal to index, what is this, 0, 1, 2, 3, 3. It means that between 0 and 3, I have duplicates. And as soon as I increase the second pointer and I get to 1, and both of these numbers are different, it means that I have a different number between that range that we have been talking about, that's duplicates. So I am just going to first increment first pointer and then replace number. That's pretty much it. And then I'm going to do it again. All right. So once again, I did do this in Paint. So if you want to get a brighter idea, if you want to get it a clear painting in your head, then just head on to the C# video and see the algorithm visually. All right, let's go start encoding. So I'm just going to go with if nums.length is equal to 0. I'm not expected to return anything, so I'm just going to go return 0. Do I even have a legit? Nums length is always bigger or equal than 1. So I'm just going to remove this check. I don't even need it here. I think I did it in the C#, but I forgot to see this. We're not going to have any problems. Well, let's go. I'm just going to say let's starting index, that's going to be 0, and then I'm just going to go this loop since I need to loop through the array, and I'm going to go let second index equals to 0, second, oops, no, actually I want to go 1, right? Because we have talked about this, we want to get the second number. We're going to have 2 pointers, and I want the second index to start from the place that's after the starting index. So that's going to be 1. I want this to happen only once. All right, so second index is equal to 1. Second index is less than nums.length. and then second index goes forward. Let me just do a little bit of, okay. And now open, close. All right. We were talking about how to find this range. Well, that's actually quite easy. I'm going to increment the second index as much as I need until I find something that's going to be different from the starting index. So I'm going to say if nums of starting index is not equal to nums of second, it means that I have found a different number. It means that second index is currently positioned here and starting index is currently positioned here. I want to keep the 0, keep in mind, because from every single duplicate item, I need to have one unique. And in order for me to keep the unique item, I need to increment my starting index to here. And then I'm just going to say this point over here is going to be equal to 1. And I'm just going to show you something. Now starting index is here and second index is here. And second index is going to come all the way to 2 here, where these are different, meaning that all of these are duplicates. Now, currently they're not. You can see the 0 here, and then we have 1s. But keep in mind that we already positioned the 0 in the array. So now I'm just going to remove the 0 and place a 2. And then I'm going to return 3 as the number to look into the array. All right, starting index. Plus first I need to go forward, and then I need to swap them. I'm not going to swap them. I'm just going to say starting index is going to be equal to nums of second index. So that's pretty much it. And finally, since now we're having the sorted array with the right positioned numbers, I'm just going to return the starting index, and then I'm going to say plus 1. If I return just the starting index, I'm going to get 0, 1, 2, and I'm going to get 2. And if I for loop this is going to be exact, right? So this is going to be index 0, index 1, index 2. But the problem is that the server is actually expecting a count of how many numbers should I be looking into the array. So obviously I'm just going to say plus 1 here because I started from 0, right? Let's run code and see if this is going to work. If we haven't messed up something, everything should be all right. Use example test cases. And then we're just going to push it to the server. Everything seems fine, so I do expect it to run successfully. All right, good. So the final thing that we need to talk about is the space complexity. Since we are using the same array here, we are having constant. We're not allocating any space for a new array here. And the time complexity, we have one for loop that goes from 1 to the end of the array, meaning that if I have 1 million elements, then I'm gonna run almost 1 million times without the 1. So this is clearly a linear time complexity. Right, that was it. If you have any questions, leave them down below. Thanks for watching. Bye.